My Inventions. Nikola Tesla's Autobiography. At the age of 63, Tesla tells the story of his creative life. First published in 1919 in the Electrical Experimenter magazine. Table of Contents. 1. My early life. 2. My first efforts at invention. 3. My later endeavors. 4. The discovery of the Tesla coil and transformer. 5. The magnifying transmitter. 6. The art of telematics. 1. My early life. The progressive development of man is vitally dependent on invention. It is the most important product of his creative brain. Its ultimate purpose is the complete mastery of mind over the material world, the harnessing of the forces of nature to human needs. This is the difficult task of the inventor, who is often misunderstood and unrewarded. But he finds ample compensation in the pleasing exercises of his powers and in the knowledge of being one of that exceptionally privileged class without whom the race would have long ago perished in the bitter struggle against pitiless elements. And so I began to travel, of course, in my mind. Every night and sometimes during the day, when alone, I would start on my journey, see new places, cities and countries, live there, meet people and make friendships and acquaintances, and, however unbelievable, it is a fact that they were just as dear to me as those in actual life and not a bit less intense in their manifestations. This I did constantly until I was about 17, when my thoughts turned seriously to invention. Then I observed to my delight that I could visualize with the greatest facility. I needed no models, drawings or experiments. I could picture them all as real in my mind. Thus I have been led unconsciously to evolve what I consider a new method of materializing inventive concepts and ideas, which is radically opposite to the purely experimental and is, in my opinion, ever so much more expeditious and efficient. The moment one constructs a device to carry into practice a crude idea, he finds himself unavoidably engrossed with the details and defects of the apparatus. As he goes on improving and reconstructing, his force of concentration diminishes and he loses sight of the great underlying principle. Results may be obtained, but always at the sacrifice of quality. My method is different. I do not rush into actual work. When I get an idea, I start at once building it up in my imagination. I change the construction, make improvements and operate the device in my mind. It is absolutely immaterial to me whether I run my turbine in thought or test it in my shop. I even note if it is out of balance. There is no difference whatever, the results are the same. In this way I am able to rapidly develop and perfect a conception without touching anything. When I have gone so far as to embody in the invention every possible improvement I can think of and see no fault anywhere, I put into concrete form this final product of my brain. Invariably my device works as I conceived that it should, and the experiment comes out exactly as I planned it. In 20 years there has not been a single exception. Why should it be otherwise? Engineering, electrical and mechanical, is positive in results. There is scarcely a subject that cannot be mathematically treated and the effects calculated or the results determined beforehand from the available theoretical and practical data. The carrying out into practice of a crude idea, as is being generally done, is, I hold, nothing but a waste of energy, money and time. I thought and planned, and conceived many ideas almost as a rule delusive. The vision was clear enough, but the knowledge of principles was very limited. In one of my inventions I proposed to convey letters and packages across the seas, through a submarine tube, in spherical containers of sufficient strength to resist the hydraulic pressure. The pumping plant, intended to force the water through the tube, was accurately figured and designed and all other particulars carefully worked out. Only one trifling detail, of no consequence, was lightly dismissed. I assumed an arbitrary velocity of the water and, what is more, took pleasure in making it high, thus arriving at a stupendous performance supported by faultless calculations. Subsequent reflections, however, on the resistance of pipes to fluid flow determined me to make this invention public property. Just to give an idea of German thoroughness and efficiency, I may mention here a rather funny experience. An incandescent lamp of 16 cp. was to be placed in a hallway, and upon selecting the proper location I ordered the monteur to run the wires. After working for a while he concluded that the engineer had to be consulted, and this was done. The latter made several objections but ultimately agreed that the lamp should be placed 2 inches from the spot I had assigned, whereupon the work proceeded. Then the engineer became worried and told me that Inspector of Deck should be notified. That important person called, investigated, debated, and decided that the lamp should be shifted back 2 inches, which was the place I had marked. It was not long, however, before of Deck got cold feet himself and advised me that he had informed Oberinspector Hieronymus of the matter and that I should await his decision. It was several days before the Oberinspector was able to free himself of other pressing duties, but at last he arrived and a 2-hour debate followed, when he decided to move the lamp 2 inches farther. My hopes that this was the final act were shattered when the Oberinspector returned and said to me, "Regierungsratfunk is so particular that I would not dare to give an order for placing this lamp without his explicit approval." Accordingly arrangements for a visit from that great man were made. We started cleaning up and polishing early in the morning. Everybody brushed up, I put on my gloves, and when Funk came with his retinue he was ceremoniously received. After 2 hours deliberation he suddenly exclaimed, "I must be going," and pointing to a place on the ceiling, he ordered me to put the lamp there. It was the exact spot which I had originally chosen, so it went day after day with variations. During another period I smoked excessively, threatening to ruin my health. Then my will asserted itself and I not only stopped but destroyed all inclination. Long ago I suffered from heart trouble until I discovered that it was due to the innocent cup of coffee I consumed every morning. I discontinued at once, though I confess it was not an easy task. In this way I checked and bridled other habits and passions, and have not only preserved my life but derived an immense amount of satisfaction from what most men would consider privation and sacrifice. After finishing the studies at the Polytechnic Institute and University I had a complete nervous breakdown, and while the malady lasted I observed many phenomena strange and unbelievable. 2. My first efforts at invention. I shall dwell briefly on these extraordinary experiences, on account of their possible interest to students of psychology and physiology, and also because this period of agony was of the greatest consequence on my mental development and subsequent labors. But it is indispensable to first relate the circumstances and conditions which preceded them and in which might be found their partial explanation. From childhood I was compelled to concentrate attention upon myself. This caused me much suffering, but, to my present view, it was a blessing in disguise, for it has taught me to appreciate the inestimable value of introspection in the preservation of life, as well as a means of achievement. The pressure of occupation and the incessant stream of impressions pouring into our consciousness through all the gateways of knowledge make modern existence hazardous in many ways. Most persons are so absorbed in the contemplation of the outside world that they are wholly oblivious to what is passing on within themselves. The premature death of millions is primarily traceable to this cause. Even among those who exercise care it is a common mistake to avoid imaginary, and ignore the real dangers. And what is true of an individual also applies, more or less, to a people as a whole. Witness, in illustration, the prohibition movement. A drastic, if not unconstitutional, measure is now being put through in this country to prevent the consumption of alcohol, and yet it is a positive fact that coffee, tea, tobacco, chewing gum and other stimulants, which are freely indulged in even at the tender age, are vastly more injurious to the national body, judging from the number of those who succumb. So, for instance, during my student years I gathered from the published necrologues in Vienna, the home of coffee drinkers, that deaths from heart trouble sometimes reached 67% of the total. Similar observations might probably be made in cities where the consumption of tea is excessive. These delicious beverages superexcite and gradually exhaust the fine fibers of the brain. They also interfere seriously with arterial circulation and should be enjoyed all the more sparingly as their deleterious effects are slow and imperceptible. Tobacco, on the other hand, is conducive to easy and pleasant thinking and detracts from the intensity and concentration necessary to all original and vigorous effort of the intellect. Chewing gum is helpful for a short while but soon drains the glandular system and inflicts irreparable damage, not to speak of the revulsion it creates. Alcohol in small quantities is an excellent tonic, but is toxic in its action when absorbed in larger amounts, quite immaterial as to whether it is taken in as whiskey or produced in the stomach from sugar. But it should not be overlooked that all these are great eliminators assisting nature, as they do, in upholding her stern but just law of the survival of the fittest. Eager reformers should also be mindful of the eternal perversity of mankind which makes the indifferent laissez-faire, by far preferable to enforced restraint. Now the engineer, who lately gave an account before a technical body of a novel remedy against statics based on a, heretofore unknown law of nature, seems to have been as reckless as myself when he contended that these disturbances propagate up and down, while those of a transmitter proceed along the earth. It would mean that a condenser, as this globe, with its gaseous envelope, could be charged and discharged in a manner quite contrary to the fundamental teachings propounded in every elemental textbook of physics. Such a supposition would have been condemned as erroneous, even in Franklin's time, for the facts bearing on this were then well known and the identity between atmospheric electricity and that developed by machines was fully established. Obviously, natural and artificial disturbances propagate through the earth and the air in exactly the same way, and both set up electromotive forces in the horizontal, as well as vertical, sense. Interference cannot be overcome by any such methods as were proposed. The truth is this: in the air the potential increases at the rate of about 50 volts per foot of elevation, owing to which there may be a difference of pressure amounting to 20, or even 40,000 volts between the upper and lower ends of the antenna. The masses of the charged atmosphere are constantly in motion and give up electricity to the conductor, not continuously but rather disruptively, this producing a grinding noise in a sensitive telephonic receiver. The higher the terminal and the greater the space encompassed by the wires, the more pronounced is the effect, but it must be understood that it is purely local and has little to do with the real trouble. In 1900, while perfecting my wireless system, one form of apparatus comprised for antennae. These were carefully calibrated to the same frequency and connected in multiple with the object of magnifying the action, in receiving from any direction. When I desired to ascertain the origin of the transmitted impulses, each diagonally situated pair was put in series with a primary coil energizing the detector circuit. In the former case the sound was loud in the telephone, in the latter it ceased, as expected, the two antennae neutralizing each other, but the true statics manifested themselves in both instances and I had to devise special preventives embodying different principles. By employing receivers connected to 2 points of the ground, as suggested by me long ago, this trouble caused by the charged air, which is very serious in the structures as now built, is nullified, and besides, the liability of all kinds of interference is reduced to about 1/2, because of the directional character of the circuit. This was perfectly self-evident, but came as a revelation to some simple-minded wireless folks whose experience was confined to forms of apparatus that could have been improved with an axe, and they have been disposing of the bear's skin before killing him. If it were true that strays performed such antics, it would be easy to get rid of them by receiving without aerials. But, as a matter of fact, a wire buried in the ground which, conforming to this view, should be absolutely immune, is more susceptible to certain extraneous impulses than one placed vertically in the air. To state it fairly, a slight progress has been made, but not by virtue of any particular method or device. It was achieved simply by discarding the enormous structures, which are bad enough for transmission but wholly unsuitable for reception, and adopting a more appropriate type of receiver.